We have a new idea coming along here, and that is that we've had a couple problems where it's been told to us what the root of a polynomial is, and then we go ahead and divide by that root. And in this situation, if you see x to the third, we'd get it down to x squared to a manageable state, and we'd factor it a little bit more maybe, but we need to get it down to x squared. Well, what if they don't give us a root? What if they don't tell us what one of the roots is? Well, that's the problem that we're going to start exploring now. And the first step in exploring the problem is to discover the possible roots, or the possible zeros that are there. And this rational zero theorem gives us a way of doing that. It's going to be the factors of the constant term at the end, a sub 0, that end there, and then on the bottom the factor, or the factors of the leading coefficient, a sub n. I kind of say, it's the last, that's at the end of the equation there, that's the last right there, over the first. You ever hear that the last shall be first? Anyway, that's what makes me think of right there. List the possible rational zeros. Okay, so we're interested in that last term, right? And it's kind of hard to see where they did it, but all these numbers on the top are factors of 12. So we put all the factors on the top, and on the bottom, it sure is convenient if there's a 1 out in front, because then 1 goes on the bottom. Then I don't really have fractions, right? Then I just go with the top numbers and I'm okay. So the possible rational functions of this, we're not saying they couldn't be something else, but if you want a rational function, if you want I don't mean to say function, the possible rational zeros, if you want a zero that's rational, it's going to be one of these, okay? And it's either plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. How many is that? 1, 2, 3, 4, 5, 6. And it's either plus or minus, so that's 12. There's 12. Happens to be the same number, which I guess is a little confusing. It has nothing to do with the fact that that's a 12, but there are 12 possibilities. And I don't want to make you feel bad, but at some point we're just going to try some. We have 12 possibilities. We're going to start trying some of those, and we'll have some tools to kind of narrow it down, but this is what we're going to do. So here we go again. This is a little bit more complicated. We have 10 at the end, so you might notice that there's factors of 10 on the top, okay, and now on the bottom we have factors of 4. So first we have the 1s, then we have the 2s. 2s are factors of 4. And then, of course, 4 is a factor of 4. So we have quite a few of them. And so how many? 1, 2, 3, 4, 5, 6, 7, 8. And there's plus or minus, so that's 16 possibilities if you want a rational function. Well, that's something. That's not little. That's not nothing. So right now we're not going to actually find the rational zeros. We are just going to say what they could be. So here's I guess I should keep the same format, huh? Here's my number on the top, here's my number on the bottom. Not the x, just the number. So I have factors of 6 on the top. And does it matter if it's negative? No. I'm going to say plus or minus. But so factors on the top, 1, 2, 3, and 6 are factors of, and it's plus or minus, of course, of 6. And on the bottom we put the first number, 1 or 2, okay? If the top's plus or minus, I don't have to worry about the bottom. So let me see. I'll have 1 plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, and plus or minus 6 over 1. And then let's see, I have some more. I have, what if there's a 2 on the bottom? Then I have Well, there is a 2. So we'll have plus or minus 1 over 2. And we'll say plus or minus 2 over 2. But wait, this is the same as this. I don't really need to write it again, do I? I guess I will, just to show that that's what I would do. Plus or minus 3 over 2, and plus or minus 6 over 2. And we'd say, hey, there's a little bit of repetition here. Don't need another 1, and I don't need another 3, because 6 over 3 that's really 3, right? And I already have a 3. So we kind of throw out those last 2, because, not those 2 on the bottom, because, you know. Okay, so I can simplify this. All the rational zeros, all the possible rational zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2, and plus or minus 3 over 2. So that's quite a few. That's quite a few possibilities. If we were gonna, it's better to know what to try than not to know anything at all. So that's good. That part's good.